What is up, most distinguished patrons of this channel? On today's episode of Fixing Broken Shit, I have a link for a piece of equipment. More or less, it has two metal bushings, one on each end, and an I-beam or an H-beam, depending on how you look at it, connecting the two of them. So we broke one end off. Well, I didn't break it, but we need to fix it. So let's get into the fixing. So for some reason, I didn't take an overall picture of what we're repairing here, but it's something like this. Now, this is a suspension link with bushings. What we're repairing does not have bushings in it. It's rigidly mounted, but the same theory could be applied to something like this as well as what we're working on. It's all kind of similar. Granted, that's tube. So let's look at another picture of what's broken. So more or less the end was ripped right off of the I-beam part, and there's a number of reasons why this happened, and I think it'll become readily apparent as we look at the pictures as far as why it broke. I mean, obviously this was abused and it was bent and hit, but the welds on it were clearly subpar, and we'll see that. Now, anytime you work on something like this, you got to ask yourself, is there any liability in this? And what I mean by this is if somebody gave you this to weld, you got to ask yourself, is this like a suspension component where if it fails that someone could get hurt or injured? If the answer is yes, that it has liability, then you should be really careful on welding it and understand if your skill level is high enough to even tackle a project like this. And you'll see why. I mean, this thing failed due to poor welds. And if you can't do better welds than what were on there, guess what? It'll probably fail again. Not to mention, you don't really want to put your name on something that maybe you can't repair adequately. And this thing has been repaired multiple times, and we'll see evidence of it. Anyways, back to this picture. One of the signs you don't want to see on something that you're repairing is a whole lot of buckshot and BBs. When you see stuff like that, you got to make a couple assumptions. One, that the person probably didn't know how to set a welder properly, therefore they had excessive spatter. Two, maybe they didn't have proper gas flow if they were MIG welding and that created excessive spatter. And without proper gas flow, your welds are probably going to be full of porosity and weak. And it's just a telltale sign that someone either didn't care or didn't have the knowledge to do a good job, both of which are bad because it means that you have to be very specific and to the point on your repair jobs, and you probably have to cut out a lot of the bad weld that's there just to make sure you're on clean metal. So step one is to sandblast what you're working on, or wire wheel it or die grind it, whatever you got to do, get it clean. Now, I'll be honest, I'm not a huge fan of sandblasting, especially with TIG welding, which is what I'm going to repair this with, and the reason's simple. Sandblasting embeds a lot of that sand and that material into the metal below the surface, and when you TIG weld it, you get a lot of sparks and potential porosity, and I've never really found it that good of a prep tool for TIG welding. For stick welding, maybe, but not with TIG, and especially not with aluminum. Luckily, this is steel. I made the determination to cut off all of that broken stuff that's still attached to that tube and grind the tube down completely clean, and then also cut a lot of that bad weld out of the I-beam. I didn't want to shorten the overall length, so I had to be careful, and you'll see what I did in a minute, but we got it clean, and we're going to cut that whole crack out. So this weld looks on face value like it was run hot. I mean, it's wetted out at the toes. We almost have undercut on the lower right-hand side. So it's like, well, that was run hot enough, right? No, it actually wasn't. And the settings that this was run at and the travel speed, it likely was done with a push angle. A lot of things were done wrong. And wait till you see how little weld was actually holding this together. Now, I do believe this was a factory weld on this part. There have been other repairs that are not factory, but this, to me, based on what I saw on the other sides, it seems to be factory. When you look at this picture, the left side, that tube, that little bit, the 1/16, 1.6 millimeter, is all of that weld that was attached to that tube. There's absolutely nothing else that was attached there. You can tell because what it ripped off was only that section. So that big, huge weld that's probably 6, 7, 8 millimeter, probably 1/4 inch or bigger in width, only attached that tube to that I-beam by that much. And that is why when it took an impact force or stress or whatever, it broke. It's simply the settings were wrong, the travel speed was wrong, the way that they were probably pushing rather than pulling on this. And you got to remember, this was done with short circuit MIG, and short circuit MIG has very little penetration when you're trying to weld half-inch thick steel to quarter-inch. And this is a perfect example of why I stress to you guys that no matter what I say or anyone else says for magical settings, you need to cut and etch your own work to see what's going on. Because if you did a test joint on this, cut it, and saw that kind of a weld penetration and fusion, you'd know that you screwed up. So clearly this company that made this didn't care. And you can see that crack kind of followed along the toe line, likely because it was very thin there and it broke where the thinnest piece of metal was. And again, the weld size isn't undersized for the material, but when only, 10% of the weld actually attached to anything, you have a pretty weak joint. Now, I stress to you guys a lot of what I call attention to details. If you're going to be bothered to repair something, don't leave crap like this. The factory left a bunch of stubs of wire because whoever did the welding didn't care, and obviously quality control didn't either because they let it out the door. But when you see stuff like this, pretty much you can universally tell yourself that the person that made it didn't care. Anytime I start seeing crap like this, I pretty much tell myself that this is something I might not want to be involved in. Like if someone came to me for a frame repair on a truck and that's what I'm seeing already, there's no way I'm going to weld it for someone and do a repair and put my name on it when someone butchered it. And I hate to say it. I mean, don't get me wrong, repairs on stuff like this get done all the time. And hey, I repaired this. But my situation's a little bit different. I wasn't doing this for a customer. This is a backup for a piece of equipment. And I know that my repair is going to last, but this is a small little item. Imagine seeing a bunch of that kind of crap on a bigger item. It might not be possible to repair it to where you know that it's going to last. And if you can't repair it to where you know it's going to last, probably don't assign your name to it. So take a pass, a hard pass on it. Anyways, let's look at the prep work. So I more or less cut the whole weld that was on there off and ground it down to clean, bright, shiny metal. Everything looked good. You can see the fit on this side is pretty good, easily TIG welded, no real issues there. Now that whole chunk of metal that was still attached to that tube, I ended up cutting all of that off, including all of the weld. So I got a pretty decent gap here, and that's all right because I can do a few passes of TIG welding off of that tube to bring it closer to the I-beam and then fuse the two together. And that's exactly what I did. But all that suspect garbage weld in there, we cut all of that out. Again, another angle you can see, pretty good fit up for about 60% of it, no issue welding. And then with TIG, I just got to build up off that tube closer to the I-beam. Now that tube is about a 1/2 inch thick from what I remember, and the I-beam was 1/4. So you're talking, 6, 7 mil to like maybe, I don't know, 20 mil. So pretty thick stuff. And this is an ideal job for a TIG repair because there's no question that you can get root fusion on thick steel like this on small short welds. With wire processes like MIG, you're going to have issues with short welds like that getting any kind of fusion because you can't build enough heat fast enough, and the starts are going to be colder than hell. So on the easier to repair side, I did one pass of TIG weld. This is a little concave, but that's all right. I'm going back for a second pass. And we know that we have root fusion here. I was running at about 160 amps or so, 150, somewhere in there. Fused that all together, did it the same on the other side, and got an initial connection between that I-beam and that tube. And this already, I guarantee you, is stronger than that poorly fused MIG weld. I guarantee you it is. But we're going to add some more metal just to add a little bit more reinforcement. So on that side, I did a quick weave, not the best work. There's some undercut on the tube, not really a huge issue because of the way that this gets stressed. And I know it's not going to break, but you should pay attention to details and take your time to do a better job than I did. Granted, it's TIG and it's going to be strong and it's fused, but not the best looking work. And basically I went around the whole thing filling in the gap and then doing sort of a weave over it. At this point, I believe I ground down some of the high spots and went over and did a final weave and cleaned it up. I don't really remember, and apparently I didn't take a picture of it. But this is looking pretty rough, but there is fusion there 100%, I'm sure. But when you're dealing in real tight spaces like this, it helps if you have an assortment of TIG cups to make sure that your tungsten and your torch can get in there. Due to the only cup I had to run a really long stick out, and you get gas coverage issues when you're running really long stick outs on small cups and poor angles. So make sure you have an assortment of cups so you can get good angles, like I said. But for the most part, this is already stronger than what was there and is unlikely to fail. Let's take a look at a couple of the other sections of this thing that I didn't repair. So on the other end, you can see again that MIG weld that likely has poor fusion. I probably should have cut some of that out or die grinded it out and ran another pass on it just to make sure, but I guess it hasn't broken yet. Now in the middle of the picture, you can see two passes that were done. My guess is it must have broke at some point right there and then someone repaired it. I'm not exactly sure. That little round weld and the straight weld next to it, that's likely factory. I'm not exactly sure why it has that round weld, but the center part of the I-beam was attached to the outer part via that. And then this is clearly a repair job, or at least something was done in here. And for all I know, maybe that is factory. You know, who knows? But I don't like seeing stuff like that where it's just gobbed in there and then a bunch of paint's put over it. I mean, it didn't look like it was repowder coated or painted after the factory, so maybe this is factory. I don't know. It hasn't broken yet, so that's a good sign, but let's face it, will it break at this point in the future? Probably. But anyways, this job is something you're probably going to tackle a lot if you start your own little side business, side hustle on repairing stuff. And it's one of those things that you really need to know that you're going to get some form of fusion with your welds when you're dealing with thick stuff like this. And you need to use TIG, in my opinion, on something like this. Stick would work. MIG for short circuit really is not going to have enough fusion on short 3/4 to 1-inch welds unless you're running like 240 amps, which most people don't have welders with that much power. So your results are going to kind of wind up like what this thing is. And it really pays to do a little bit of a test weld on the same thickness material, same joint configuration with your settings and see what happens, because you don't want the experiment to happen on a customer's product where it breaks later. You can figure out whether or not your settings or your machine will work by simply doing a test plate with the same setup, and that's what I would recommend. Now, could short circuit MIG weld this? Yeah, it could above 200 amps if your joint preparation was really good, clean material, and you knew what you're doing. But honestly, this is a job for stick or TIG with this thick a material, or spray arc or dual shield wire with wire processes. Anyways, that's pretty much it for the repair video. If you got any comments, questions, thoughts, feel free to leave them. Until next time.